What is up, guys? This is the CSpreneur, and this is actually our last tutorial, but it is a hard one, so strap in and let's get started. Okay, so today we're going to be covering line following, and it's a very complicated topic, but I think based on what we covered last time, and if you guys got what we covered last time, you guys should be more than fine. It's just very simple step up. So let's head over to the computer. So I have a little graphic for you guys that I downloaded, and so what you see here, you see a black line, and what we want the robot to do is actually follow the black line. So why don't you guys pause for a second and think how you can do this. Okay, so I've assumed that you have gotten a chance to pause the video and just work through it just a bit. It's very hard the first time around. Actually, I had no clue how to do it the first time, but I heard this genius idea, and my mind was just blown. So let me tell you how most people follow the line. So you guys, some of you may have thought that you could follow the line, just within this black area right here. And just check to see whether there's any white, and some people do that. It's a very the robot's very prone to getting off track. You don't know which way to turn and things like that. So here's how most people follow the line. Ready? They follow it on the edge. Is anyone's mind blown yet? Because mine sure was the first time. Okay guys, so if you notice the lighting change, I got cut off because my SD card was full. Oh well, continuing off where we left off last time, we discussed the concept of following the line on the edge. And let me discuss why this is so crucial and necessary. Okay, so if the robot were to follow, just follow my box here. If the robot's light sensor were to be on the line and detect all the black, then if the robot went forward over here, then it wouldn't know which direction to turn. So if it went over here, then it wouldn't know that it needed to turn in one direction versus the other. Whereas if it's on the edge, then it knows which way to curve according to whether it's more on the black line or more on the white line. And let me explain that in just a bit here. Okay guys, so I'm back for the third time. My camera battery just went out of charge, so let's hope I can finish up the video. Anyways, so back to where we started. We were talking about why we should follow the line just right in the middle of the white and black here, and that's because on the edge of the line, if the robot is too far on the white edge, then it knows to curve in one direction. So anywhere on this line, if the robot is too much on the white, then it's going to get a higher value than 50, which means it knows that it needs to curve, I guess, in the right direction. So just forward right. So I guess that's either this way or this way, based on whether I'm getting hold on, so forward right would be this way. So yeah, to you guys it would be this way. Yeah, that's right. Okay, sorry, my bad. Okay, so if the robot was towards the black line and it was following this edge of the line, and if it was too much on the black, then it would know that it would need to curve left. And so that's why we follow the edge of the line as instead of following just the black line, because it doesn't know which way to turn. Unless you have two color sensors, which most people don't have. But anyways, let's discuss the logic and how to actually implement this in the NXT coding language that I should have pulled up right here. Okay, there we go. So instead of these blocks and instead of the infrared sensor, what sensor are we going to use for this? Just go ahead and pause the video. So if you guys said color sensor, then you're right. And are we going to use measure or compare? Right, so compare. We're going to be using compare, and we're going to be using reflected light intensity. And so typically, roughly what you're going to get for a black line completely is somewhere around 8, a value of 8. But if you're somewhere around 96 to 98 for a white line. So if you just average that, you're roughly going to get somewhere around 50. So 50 is just fine. So as per the logic, let's just say that if the robot is, or if the value coming from the light sensor over here is, let's say, less than or equal to 50, then what does that mean? That means the robot is more towards the black line because the value coming from that is less than 50, right? So if that is true, so if that's true, then if that's a check, then what do we want the robot to do if we're following the, let's say, the left side of the line over here? We want the robot to curve to the forward left side so that it can get more towards the white side. So let's assume that the robot is right here. Then this portion of the loop would be executed because this the value coming from the switch or the color sensor is indeed less than 50. So let's go ahead and create a steering block, and let's create on. And so notice that we have the steering, as I told you before many videos ago, this is basically like the steering wheel in a car, and we want to just tilt this ever so slightly to the left. And so we want to do the same thing, so I'm just going to use Control-C and Control-V, and I'm just going to drag this block down here, and I'm going to make this 20 just to curve the opposite way, because if the value is greater than 50, then that means that we're too much on the white, which means that we want to curve back towards the black, just in our happy medium right here. So if you guys go ahead and run this code, just go ahead and pause the video and go ahead and run this code and come back and just continue playing this video. Okay, so I'm assuming that you guys had a chance to go do that, and you guys might have noticed something, and that is the robot is jerking around like crazy, right? Or it's just, going super fast and might even be losing the line. And that's because we are having a power of 75. And so if we have a power of 75, then the robot's going to give more power to the wheels. So how can we correct that issue? We're using the power. Can anyone tell me? Well, go ahead and pause the video. And if you guys guessed that we should lower the power to roughly, I don't know. So, well, if you guys guessed that we should lower the power, then you're right. I would suggest that you guys lower it somewhere around 25 just from experience. You guys can also go up to 30 or 40, but I think 25 is just the a good number to use. So go ahead and run this code and tell me what you see. Okay, so if you guys went ahead and ran this code, then you guys should have seen that it was working perfectly. It should be working at least. Let me just check one thing here. Let's just go ahead and delete this. Sorry, it was just looking weird. Just drag this block back in here. Okay, perfect. So if you guys just ran this code, then it should be good. But let's say that I want to stop following the line after 10 seconds. Can anyone tell me how to do that? So if you guys guess that we should change this unlimited to a timer and set the time to let's say, oh, 1 second. My bad. 1 second, sorry. Interesting. Wait, no. Not timer. Time. My bad. I'm sorry. That looked really weird for some second. For 1 second. So, if you guys said that we should change this time to 10 seconds, then you're right. So we're just going to be following the line for 10 seconds. Now, can anybody tell me how to get the robot farther in these 10 seconds? Well, if you guys guessed that we should increase the power to somewhere around 40 or 50, then you're right. Now, obviously, you're going to be losing a bit of accuracy along that line as you increase the power, but that's fine. If you guys are wanting to go fast, then that's also good. Now, let's say that there's a line heading straight into a wall. What do you guys think we should do? Then we should, and you want the robot to stop before crashing into the wall. Obviously, we should use the infrared sensor, and we could just check proximity. And instead of using equals, because as I told you, equals is just one particular moment in that section. Instead of using just equals, we're going to use less than or equals to. And let's say that the distance between the wall and the place that you want to stop is somewhere around 20. And again, you guys can measure this using the port views, and make sure that you guys make use of that during the challenges if you guys are doing this at school. Then let's assume that you find a value of 20, and so that if the value of that, the robot the distance between the robot and the obstacle is 20, then it'll detect that either right then and there when the distance is actually 20, or when it moves just a bit into the zone. And so that's why we use less than or equals to, because the robot's not always perfect. And so yeah, that's basically line following in a nutshell. Thank you guys so much for following along with the course. Hope you guys had a blast, and go ahead and follow the CSpreneur if you guys want to learn more coding. I'm going to be teaching Python, Java, Objective-C, and more as time comes. So go ahead and follow the channel, go ahead and subscribe, go ahead and like, comment, share, all those things. And if you guys are following along from school, this is the last tutorial. Thank you guys so much for participating. I hope you guys had a blast with playing around with the kits, and I hope you guys learned something new. So go ahead and just leave in the comments, just tell me what you guys would like to see more. If you guys would like me to change anything in the program, go ahead and let me know. And that's all, guys, so thank you so much for following along, and we'll see you in the next tutorials.